Okay, so this is your intro into writing linear equations from given graphs for Monday. So again, we looked at Friday, we looked at a video on understanding what is the equation y equals mx plus b really mean. And so we just took a test on given, learning how to identify slope from tables, learning how to identify slope from graphs, y-intercepts from tables, y-intercepts from graphs, put it all together. And so what we're going to start doing now is writing these equations. So from the video, what you guys should have got was that the y is actually what we call the output. And so after I put something into the equation, do some math, and then I get an output. X is what we call the input. And then we have these two new letters that we're not used to seeing, right? Is the M, and then we have the B. Okay, so if you watch the video and you completed the activity on Friday, what we found was that the M really is just the slope, right? It's how we move down the line. The B is going to be our y-intercept. Okay, that's where it begins from, right? In a one-quadrant graph, that's how you can remember. The way to remembering that is that if I have a one-quadrant real-world graph, where does the line begin from? That's my y-intercept. That's the B in the equation y equals mx plus b. All right, so what you guys are going to look at today is actually how do we write the equation given a graph. Friday, you guys were given the slope and given the y-intercept, and then you had to create the equation or match the equation. Today, you're not given it, you actually have to go find it. But we've already done that, so let's now basically we're putting it all together. So let's go take a look at an example. So I want to know what's the equation of this line. So again, we're looking at y equals mx plus b. That's what we're writing this in. Now, what we do know is that two things will always be constant in these equations: the y equals and the x. What's going to change and what's going to be different is going to be dependent on the situation. Is what do we get for m and what do we get for b? Okay. Now, I do want to take notice that it does say plus in here, but it won't always be plus. So like we talked about on Friday, if we have a negative y-intercept, then this turns into y equals mx minus b. Okay, so negative y-intercept goes to minus, positive y-intercept a plus. All right, so when you're looking for graphs and we're looking to write these equations, we're always going to start with looking for that y-intercept. Where does the graph begin, or where does the graph cross that y-axis? Again, the y-axis is this guy right here. So where does the graph start? In this case, because it's a one quadrant, on the y, and we see that it starts right there. So my y-intercept here, my b, is equal to a positive 500. So I can fill that in for my equation now. So I do know that b is 500, so I'm going to write plus 500. So that's telling me where the graph started. That's where it's going through the y-intercept. Okay? Or y-axis, excuse me. It's the y-intercept. All right, so now what we need to do is figure out the slope. So remember, when we looked at slope from graphs, the step one to find slope was to build a x, y table with perfect points or input-output points. So for example, if I inputted a 0 for x, I did the equation, kicked out a 500 for y. I come in here and look for another perfect point. I see a perfect point right there. So when I input a 10, I got a 100 for y. So a couple things we notice. My y's are decreasing as my x's increase. So they're moving in opposite. The shape of the line, if I'm just looking at the shape of the line, is going down. So that tells me that more than likely my m is actually going to be negative. So let's go figure out how much we're moving down in this case. So 500 to 100 is a minus 400. 0 to 10 is a plus 10. Well, then I'm going to take 400, negative 400 divided by 10, and that comes out to negative 40. So in this case, my rate of change, or my slope, is negative 40. So in this case, now all I have to do is take this and plug it in here. and then there's my equation. So y, the output, is equal to negative 40 times the input of x plus 500. And so you can check your work by saying, okay, let's plug in a 0. Negative 40 times 0 is 0, plus 500 gives me 500. 0, 500, we're good to go. 10 times negative 40 is negative 400, plus 500 is a positive 100, and so that's what I have there as well. Okay, so that's looking at a one quadrant graph. Let's go look at what we do for a full quadrant mathematical graph. So again, here we have a 4-quadrant mathematical graph. I'm still looking for the equation of the line in y equals mx plus b. And remembering that m stands for slope and b, don't want to do that one, I'll highlight. And b is the y-intercept of where the graph begins. Now we notice we don't actually have a beginning value here. That's why we call this a mathematical, not a real world. So we still have a y-intercept, and again the y-intercept is where does the line cross that yellow line, that y-axis. So where does the blue and the yellow touch? That's what I want to know. Okay, so again, step 1, looking at graphs, we're going to look at the easy stuff first. Right? Where is that y-intercept? So the b, we don't have to hunt for it, we don't have to find it, we just have to see it. So my b, well, the blue and the yellow touch right there, and that's going to give me a positive 1, 2, 3, so plus 3. Now slope, on the other hand, remember, we're going to need to build a table. Right? We're not changing our processes, we're looking at graphs differently, but the process is still the same. I want an input-output table, or an XY table of perfect points. So when I input a 0, my perfect point is 3. So I'm going to look for another perfect point. So there's one there, and then there's one there. So I'll put them all in the table, but remember, we only need 2 of these. Okay, we only need 2 of these to find the slope. So we could use 5, 2, or if you wanted to, you could use negative 5, 4. I'm going to stick with these 2, so I don't have to work with negatives. But again, all we need is 2, so the choice is yours. Now again, what do we notice about the slope here? Well, it's going in a downward direction. I also notice that my y's are decreasing as my x's increase. So they're moving in opposite, so more than likely, and not more than likely, it is going to be a negative slope. So 3 to 2 is a negative 1, 0 to 5 is a positive 5. My change in x over change in y, change in y over change in x is negative 1/5, and we can leave it like that. More than likely you'll see it written as a fraction, but if you don't for some reason, it can also be negative 0.20. Okay, so now all I gotta do is just build my equation. Again, constants output is equal to the slope times the input, and then we have the slope here is negative 1/5, and then my y-intercept here is positive 3. So again, you can check it. Plug in a 0. What is negative 1/5 times 0? Well, anything times 0 is 0, plus 3 is 3. Plug in a 5. Negative 1/5 times 5 is negative 1. Plus 3 gives me a positive 2. So those all check out. And then negative 5 times negative 1/5 is positive 1. Plus 3 is positive 4. So again, reviewing the steps here.